Look outside your window. Take a moment to really notice what's out there. The trees, the grass, and especially the birds that flit and hop around your garden. See that sparrow or pigeon perched on a branch or fence, pecking at seeds or preening its feathers. You're not just looking at a bird, you're looking at a living dinosaur, a direct descendant of creatures that once ruled the earth. Birds are the direct descendants of a group of meat-eating dinosaurs called theropods, the same family as the mighty T-Rex and the agile velociraptor. This isn't just a poetic idea, it's a scientific fact, revealed by over a century of fossil discoveries, careful research, and new technologies that let us peer into the distant past. The journey from ground-dwelling dinosaur to flying bird is one of evolution's greatest and most fascinating stories, full of unexpected twists and turns. Theropods weren't all giants. Some were small, nimble, and covered in feathers, darting through prehistoric forests in search of food and safety. Over millions of years, these remarkable creatures evolved, adapting to changing environments and giving rise to the 10,000 bird species we see today, from hummingbirds to eagles. Every bird you see is a tiny modern theropod, carrying the legacy of its colossal ancestors in its bones, feathers, and even its walk. Their anatomy and behaviors echo a lost world. Look closely, and you'll see hints of ancient claws, scales, and even the way they move. The transformation from dinosaur to bird was gradual, a series of small, almost invisible changes that added up over millions of years, shaping new forms and abilities. Each adaptation, feathers for warmth and display, lighter bones for flight, new ways of moving and feeding, opened up new possibilities for survival and success. Birds are the only dinosaurs to survive the mass extinction that wiped out their relatives, enduring when almost everything else vanished. So next time you see a bird, remember, you're witnessing the living legacy of the dinosaurs, a story that began over 150 million years ago and continues right outside your window. The story of birds is the story of survival, transformation, and the incredible power of adaptation. That robin in your garden is a direct link to a prehistoric past, a living bridge between ancient worlds and our own. The journey from earthbound predator to aerial acrobat is a testament to evolution's power, creativity, and resilience. Dinosaurs didn't simply vanish, they took to the skies, reinventing themselves in the face of catastrophe. This is how they conquered the air, survived the apocalypse, and became one of the most successful groups of animals on the planet. For decades, the idea that birds descended from dinosaurs was dismissed by most scientists. The textbooks and museum displays of the time showed dinosaurs as scaly, lumbering reptiles, and the connection to birds seemed far-fetched. But then, the fossils began to tell a different story, one that would challenge everything we thought we knew about dinosaurs and birds. The first big clue was Archaeopteryx, discovered in 1861. This remarkable fossil had feathers and wings like a bird, but also teeth and a long, bony tail. Features straight out of the dinosaur lineage. For years, Archaeopteryx was a lone puzzle piece, a strange outlier that didn't quite fit with either birds or dinosaurs. Then, in the 1990s, farmers in China's Liaoning province unearthed fossils that would change everything we thought we knew. These extraordinary fossils preserved not just bones, but delicate feathers, clearly visible on unmistakable dinosaurs, not just ancient birds. Suddenly, paleontologists were looking at small, meat-eating theropods covered in dino fuzz, a kind of primitive feathering. These weren't birds, but true dinosaurs with primitive feathers. Evidence that feathers evolved before flight. Fossils like Sinosauropteryx showed simple, hair-like filaments, likely used for insulation rather than for flying. Later discoveries revealed even more complex feathers, some arranged in wing-like patterns, hinting at new uses for feathers beyond warmth. The evidence showed that feathers evolved step by step, in a gradual process that began long before the first true bird took flight. Today, dozens of feathered dinosaur species have been found, ranging from tiny agile runners to larger, more formidable predators. Feathers were a dinosaur innovation, not just a trait of birds. They served many purposes: display, warmth, and eventually flight. These discoveries have completely rewritten our image of dinosaurs. Many were vibrant, feathered, and surprisingly bird-like in both appearance and behavior. The scaly monsters of old movies have been replaced by a new, more accurate reality, one that's even more fascinating. The detective story had its breakthrough, Birds are living dinosaurs, the last survivors of a once mighty lineage. The fossil record now reveals a clear evolutionary sequence, connecting ancient dinosaurs to the birds we see today. Feathers, once mysterious and misunderstood, are now a key to understanding the incredible story of dinosaur evolution. The connection between birds and dinosaurs is undeniable, visible in every flap, strut, and call of modern birds. The evidence is written in stone, waiting for us to read the ancient detective story preserved in every fossil. Early feathers weren't for flight, they were for warmth. Dino fuzz helped small, active dinosaurs regulate body temperature, hinting they were warm-blooded. As feathers became more complex, they took on new roles: display and communication. Some dinosaurs used colorful plumage to attract mates or intimidate rivals. Fossils even preserve pigment cells, revealing stripes and iridescent sheens. Feathers became tools for social interaction, not just survival. Only later did feathers evolve into the asymmetrical shapes needed for flight. The classic flight feather with its airfoil shape was a game-changer. Dinosaurs like Microraptor and Archaeopteryx had these feathers. Flight was now possible. What began as insulation and display became the key to conquering the skies. Feathers tell the story of adaptation and innovation. The bird-dinosaur connection goes deeper than just feathers. It's a story written in bone, muscle, and movement, an ancient legacy that lives on in every bird you see today. Look at the skeleton. Birds are built on a dinosaur blueprint, their bodies echoing the forms of their prehistoric relatives. The wishbone, once thought unique to birds, is found in theropods like Velociraptor. This bone, crucial for flight, first appeared in dinosaurs. Hollow bones, essential for flight, first evolved in dinosaurs for an active, fast-moving lifestyle, long before birds ever took to the skies. Theropods had air sacs and a one-way breathing system, just like birds. This efficient system powered their high-energy lives. Three-toed feet and specialized wrist bones link birds directly to their dinosaur ancestors, showing a clear evolutionary path. The semilunate carpal, a swiveling wrist bone, let theropods snatch prey, and later, allowed birds to fold their wings with precision. These aren't random similarities, they're inherited features, passed down through millions of years of evolution. Birds didn't invent these traits, they inherited a ready-made toolkit, a set of adaptations honed by their dinosaur ancestors. The dinosaur hand became the bird wing, transforming over time into the perfect tool for flight. The evidence is in every bone, every joint, each one a clue to their shared history. Birds are theropod dinosaurs, refined by evolution into the diverse creatures we see today. Their skeletons are living fossils, carrying the story of their ancient origins. The family resemblance is unmistakable, visible in every detail of their anatomy. The story of birds and dinosaurs is written in their bones, a living testament to evolution's power. How did dinosaurs take to the air? Two main theories compete. The trees-down model suggests small, feathered dinosaurs glided from trees using feathers to control descent, like Microraptor, the four-winged dinosaur biplane. The ground-up model argues flight began, with fast runners flapping their arms for balance or to climb slopes, as seen in young birds today. Both theories have evidence, and the truth may combine elements of each. The flight stroke likely evolved from motions used to catch prey or run. However it began, flight was a gradual process. Small steps, big consequences. The leap into the air changed everything for dinosaurs. Archaeopteryx is the fossil that started it all, a perfect blend of bird and dinosaur. Discovered in 1861, it had flight feathers like a bird, but teeth, a long bony tail, and clawed fingers like a dinosaur. It lacked the deep breastbone of modern birds, suggesting weaker flight. For years, it was the only known transitional form. Now we know it was one of many feathered, bird-like dinosaurs. Archaeopteryx marks a key milestone in bird evolution, a capable flyer, but not yet a modern bird. It shows evolution in action, old traits mixed with new. No longer a missing link, it's a solid connection in the chain from dinosaur to bird. Archaeopteryx is a beautiful snapshot of transformation. Early birds like Archaeopteryx were just the beginning. Evolution refined the dinosaur body for flight. Long tails shrank into pygostyles, anchoring fan-shaped tail feathers for steering. The breastbone developed a keel for powerful flight muscles. Hand bones fused, turning grasping claws into rigid wings. Heavy, toothy snouts became lightweight beaks, perfect for flight and feeding. Brain regions for vision and balance expanded, mastering the aerial world. These changes appeared gradually, but when disaster struck, only the most efficient flyers survived. Modern birds are the ultimate flying machines, dinosaur design, perfected. Every bird is a living echo of the dinosaur age. Their hollow bones, feathers, and sharp eyes are ancient innovations. Evolution didn't create birds in a single leap. It was a journey of countless small steps. Feathers for warmth became tools for display, then for flight. Old structures found new uses, building complexity from simplicity. When the asteroid struck, it was the adaptable feathered dinosaurs that survived. Today, birds thrive on every continent, a testament to resilience and change. The dinosaur dynasty lives on in every chirp and flutter. Each new fossil adds to this epic story. The transformation from dinosaur to bird is proof that even the most fantastic changes are possible.